All right, so good afternoon, students, and welcome to this weekend's lecture. I think Madam Beta informed you about the change of our time from Saturday to Sunday at 12 midday. So we are going to keep this time on Sundays for our lecture, starting from 12 midday till we finish at 2 p.m. So those who are not aware, I want the class rep to inform them that our business statistics time has changed from Saturday to Sunday, 12 midday to 2 p.m. A quick recap of what we did last week. So last week was introductory. We were learning how we are going to change data into information this semester using various techniques. And then once we get the information, we also take our decision from the information we have created or found in data. So data will be our main source, and then we use various techniques as a tool or various approaches as a tool to transform the data into information. And then once we get the information, a quality decision can be taken out, like I displayed in our roadmap last week. So we are still working with the roadmap. And because we are business specific, we will transform business data into business information. Then we also transform the business information into business decisions. And let me repeat one more time. The tool we are going to use are called statistical techniques. Statistical techniques, which I did explain some of them last week. So today we are going to use one of them. We are going to use one statistical technique to transform business data into business information. Then out of that, we take a decision. And the specific technique we want to use today is called the frequency analysis of data. Frequency analysis of data. So this is the first technique we want to use, and we can start with that and see where we get with this today. So there are several components in the frequency analysis technique. So in frequency analysis technique, you are required to find the following: to find the frequency of data. Find the frequency of data. And this you can do, frequency of data, you can find this by tallying numbers. So you'll be given a lot of scattered numbers, and then you tally these numbers, which you were doing at the first cycle and second cycle level. Then a new thing you will learn today is that just after the frequency of data, you find a metric called relative frequency. Relative frequency. And for relative frequency, the formula you will use is as follows. So your RF, relative frequency, is equal to rho frequency divided by total frequency. And then when you add up all these relative frequencies, your total value should be equal to the number 1. That's the second component of the frequency analysis. Then the third component we'll look at today is called the percent frequency. And the formula for the percent frequency is also the relative frequency you have multiplied by 100%. So you multiply it by 100%. Again, the total value you should have here should also be equal to 100% at the end of the day. That is the third component of the technique we are looking at today. Then the fourth one is called the cumulative frequency. So the cumulative frequency is also done by adding previous frequencies. Previous frequencies to current frequencies. You add previous frequencies to current frequencies. Then the next component number 5, is also called the relative cumulative, or let's put it this way, the fifth component, let me change the name to cumulative relative frequency. So let's rewrite this one again. For the fifth component, we have the cumulative cumulative relative frequency. And that also has this formula as rho cumulative frequency, rho cumulative frequency divided by total divided by the total frequency. That's component number 5. And then the last component, component number 6 for our technique today, is also called cumulative percent frequency. And that also has this formula, C.R.F. So cumulative relative frequency is what I have shortened as C.R.F multiplied by 100%. So these are the 6 components. If I'm to write them in order for you to see, this is what I said we are going to do. Frequency F followed by 2 relative frequency, then the third one is percent frequency, the fourth one is cumulative relative, no, the fourth one is cumulative frequency. Okay, the fourth one is cumulative frequency. The fifth one is cumulative relative frequency. And then the sixth component is the cumulative percent frequency. So in the final analysis, we put all of them in a table, and this is what the arrangement will be. We draw a line from end to end, long line like this. And then when we start our table, we'll start our first column with our class intervals. Then from our class intervals, we do our tally. From our tally, we have our frequency. After the frequency, we'll have our relative frequency. Then the next will be our percent frequency. Then after the percent frequency, we'll have our cumulative frequency. The next will be the cumulative relative frequency. Then the last, but not the least, will be the cumulative percent frequency. So this technique is giving us 1, 2, 3, 4, 5, 6, 7, 8. 8 columns. Then the objective of this technique, is to extract information from data. That is what this table will do. Its objective is to extract information, extract information from data. And so pick an example and then we'll work the example out for you to see how these columns, when you put all together, the technique is called the frequency distribution analysis. The frequency distribution analysis, FDA. So we can now pick some sample problems and see how we formulate all these 8 columns and then get our answers, analyze and see how we are going to extract information from the data we are given. So our first example for today is this hostel story here. There's a certain private hostel that some guests went to lodge. And as we do, sometimes you need to prepare a questionnaire for them to give their feedback. There are certain organizations, when you go there, they will put some box there like this and say this is a suggestion box. Suggestion box, meaning that they need some information from you to improve their services, to improve their services to their potential clients. Some also don't put suggestion boxes. What they do is that they design a short questionnaire for you to fill before you leave. So the questionnaire is in the form of rating, like rate their services, whether their services is excellent or their facility is excellent, or you think it is above average. So these are the options you see on the rating: above average, or it is average, or below average, and then finally poor. So you are going to rate it. You have 5 options: the first option, the second option, the third option, the fourth option, the fifth option. So this is an example. And all this stuff you are seeing here, starting from this end to this end, this can be classified as raw data. Raw data. Because it's just been recorded and you cannot see any information yet from this one. The only way you can have an information from this is for you to process this data. If you don't process this data, there's no way you can get information from it. Because in statistics, we say that information is always hiding in data. Information is hiding in data. And so you need to extract it. Okay. There are much information here we do not know until we process this data. So we'll try and process this data with what we have learned today about the 8 columns I did for you. We are going to use the 8 columns and we are going to process this data using the FDA, frequency distribution analysis. That is what we are going to use to process this data in order to have information. So let's do our table and then we can process this data. So I'm going to draw the 8-column table again for you. And then we'll start picking the necessary data we need. Use the formulas for the components. And then we can then get a resource we can interpret. And I'm sure you remember the 8-column table, which we just did. I repeat same here. So I have my pen, I have my pencil. Now let me draw from end to end the kind of table we want to use today. So we start from this end and we move right down to the right-hand side. And then I'll stretch it this way. Because of space, I'll just manage the space I have here. And we can do the analysis. Now, any data that does not come with numbers, but are written in words like this, we have a name for such a data. And such a data, we call it a qualitative data. Qualitative. It doesn't come with numbers, come with words. Qualitative data. When we are done with this and there is time, then we go and pick the opposite of this, which is called a quantitative data. Quantitative data come with numbers, and then qualitative are non-numeric. They don't come with numbers. And I want to prove to you that the technique we are using today can work for both qualitative data and then quantitative data. So let's start with this qualitative data. So with the table, let's start from the first column like we did. I said the first column, you label the first column as your class intervals. So that is the label we give the first column. That is our class intervals. So some also shorten the class intervals and then they are called classes. You can either write classes or class interval. Then our second column, we have our tally column. Then we'll convert our tally into our frequency. Immediately after the frequency, then we'll have our relative frequency, which I will abbreviate as R dot F. So when you see R dot F, it means relative frequency. Then after the relative frequency, we'll have our percent frequency, which I'll also abbreviate as P dot F, percent frequency. After the percent frequency, we'll have our cumulative frequency. So we are writing them in order of how we started. After the cumulative frequency, then we have the cumulative relative frequency, or the CRF. Then finally, the last column, which is the eighth column, we'll label as CPF, cumulative percent frequency. Cumulative percent frequency. So these are the 8 columns we can use to process this data. Let's read and get understanding of the data. It says guests staying at a certain private hostel were asked to rate the quality of their accommodations as being excellent or above average or average or below average or poor. So these are the 5 options. After sleeping in the hostel, they have been asked to rate the quality of the accommodation, whether it's excellent, above average, average, below average, or poor. The question continues. The ratings provided by a sample of 20 guests. The ratings provided by a sample of 20 guests are shown below. So these are the ratings by the 20 guests. So it means that guest number 1 said the ratings were below average. Guest number 2 also said the ratings were above average. Guest number 3 said the rating is average. Guest number 4 said the rating is average. Guest number 5 also said the rating is above average. Guest number 6 said it is average. Number 7. So it continues like that. So you have all these responses coming from the guest. So this is for guest number 8. This is for guest number 9. This is guest number 10. Guest number 11 said it is poor. Guest number 12. Guest number 13. Guest number 14. Guest number 15. Guest number 16. Guest number 17. Guest number 18. Guest number 19. And then guest number 20. So these responses from these 20 guests are forming the raw data you are seeing. They have just given us data. But you, as the manager of the facility, you are supposed to process this data in order to have an information about what they are saying or telling you or recommending. So we'll use our technique today, which is the frequency analysis table, to try and understand the information these 20 guests are trying to tell the manager of the facility. So these were the classes. We had some who said the facility was excellent. So that is the first group. Or let's even start. Let's start with the list. Let's start with the poor, those who said it was poor first. And then we descend to the excellent ones. So there were some who said, according to the data, the facility was poor. That's the first group. So this is their line of information. Then the second group said the facility was below average. We'll give them the second line. So they take the second line. Then those who said the facility was average in nature, they form the third group. So we give them the third line to get their information. Then the next group said the facility was above average. So the above average group, we give them the fourth line. So this is above average. Then the last group, they said the facility was excellent. So they have the fifth line, and then probably the last line here, we say this will be the total for all of them. So this is our plan. We are grouping them, the data, into poor, below average, average, above average, excellent. And then we use, this is the information table. Then the information table will be picking their source from these classes. So let's go and do the very things the tally. Let's start with poor. Let's check how many chose poor. And then we tally and write the frequency. So this is the data. If you scan through the data, I see poor here. So this is tally number 1, poor. And then this is tally number 2, poor. It means 2 people chose poor. So we go to our table and then we record. So tally is 1, 2. And so when you change the tally to frequency, you have 2. 2 people chose poor. Then the next group, below average. Let's see how many chose below average. We are done with the poor, so I cancel it out. So below average, I see 1 here. So this is 1 below average. For this side, I see only 1 below average. I see a second one here. So I also have only 1 in this block. So 1, 2, below average. I see a third one here. So it means that when we go through the data, those who chose below average, I'm seeing 1, 2, and 3. So there are 3. So we go to our information table and record. We had 1, 2, 3. So you record the 3. Then the next group is those who chose average. So let's look at those who chose average. Let me cancel out the ones we are done with. So this is done. This is done. Okay. So we are looking for average. Average, I see the first one here, average. And then I see the second one here. So this is number 2, average. This is number 3, average. This is number 4, average. This is number 5, average. And I think that is all. So average, we have 5. 1, 2, 3, 4, 5. We go to our information table and then we record it. 1, 2, 3, 4. Then the 5th one, you cross. So you have 5 people saying the hostel facility is average in quality. Then the next group is above average. Let's tally those who chose above average. So this is done. Let me cancel it out. This is also done. This is done. This is done. That is done. We are now at above average. So above average, I see the first one here. So this is 1. This is 2, above average. This is 3, above average. This is 4, above average. This is 5, above average. This is 6, above average. This is 7, above average. This is 8, above average. And this is 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So above average is giving us 9. We move to our table and then we record the 9 we are having for above average. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 for above average. And then the last option, excellent. Let's see how many chose excellent. So excellent, I see 1 here. And that is all. I'm not seeing any excellent again. So it means that those who chose excellent is only one person who chose excellent. Let's go to our table and record. So excellent is 1. And then we have 1. Now let's check the total. They are 20. So when we add our frequencies, we must get 20. 2 plus 3 is 5. 5 plus 5 is 10. 10 plus 9 is 19. 1 plus 19 is 20. So we are correct. The total frequency is 20. So the first 3 columns, we get the information from the question. Then for the rest of the 5 columns, we are going to use the short notes we wrote today to fill the rest of the 5 columns and get our results. So the RF, let's pick the RF formula. The RF, we said RF, the relative frequency, is equal to the row frequency divided by the total frequency. So we move. Now, the first one is 2. So we do 2 divided by total frequency is 20. 2 divided by 20, when you work it out on your calculator. So at this point, I will encourage you to pull your calculator to be doing the calculations alongside with me. 2 divided by 20, when you do this on your calculator, you end up recording 0.1. 0.1. 2 divided by 20, you have 0.1. So we record our first RF at 0.10. You can leave your answer in 2 decimal places. 0.10. Then the next one is 3. 3 divided by 20.
Yes.
Next one is 3 divided by 20. And when you do that, what do you get?
0.15.
0.15.
0.15.
Very good. 0.15 for the second one. 0.15. Good. Then we move to the third. 5 divided by 20. What do you get?
0.25.
25.
0.25.
Very good. 0.25. Then 9 divided by 20. What do you get?
0.45.
0.45. Very good. Then the last one, 1 divided by 20. What are you having?
0.05.
0.05.
0.05. Very good. So when I was giving you the notes, I said when you are done and you add all the RF, your final answer should be 1. So check on your calculator. When you add all this, check whether you get 1.
Yes, sir, it's 1.
Very good. So it means we are correct. Anytime you finish and you add and you don't get 1, it means there's a problem somewhere. You need to go back and check. Always your total should be 1. So let's move to the next column, PF. PF, the formula we wrote today, we said it is the RF you have just gotten. Just multiply the RF by 100%, and then you get a PF. So the first one, when I take 0.10 and I multiply by 100%, I'm going to have 10%. For the first one, I'll have 10%. Second one, when I multiply 0.15 by 100, that is also going to give me 15%. The third one, 0.25 multiplied by 100%, I'll have 25%. The fourth one, 0.45 multiplied by 100%, have 45%. And then the last one, 0.05 multiplied by 100%, I'll have 5%. In the same way, I said the PF, the total value, when you add everything, you should come back to the 100%. Once you get the 100%, that means that what you have done is correct. If you don't get it, it means you need to go back and then redo it. So that is for the PF. Then we move to the next column to do the cumulative frequency. So you see what we are doing as business analysts. We were just giving this data. And this data, when you look at this data on the surface, or like we say, the face value, you don't see any information in it. You don't see the 15% we are writing. You don't see the 20% we are writing. You don't get any information from it unless you process it. So that is basically what we are doing. The ordinary person who is not analytic will not see that there is information in this. All they will see is that you have just written average, below average, above average, excellent, poor, and that is all. So what we are doing at the end of the day, we'll come back to this data, and then you realize that some information were hiding in this data that we didn't know until we process them with what we are doing. We cannot know the information that is hiding. And that is why I have brought you back to look at the data again. That look at the data in this state. It doesn't make sense. It is just raw. But we are making information out of this data. So let's continue with the process. Now, we are here, cumulative frequency. And you were taught to do it this way, that anytime you are doing cumulative frequency, you repeat the first frequency, which is 2. So you repeat it as 2. Then for the second one, you add this 2 to the old second line here before you record. So we go this way, 2 plus 3, and that will give you 5. You write your 5 here. Then you pick this 5, 5 plus 5, you are having 10. Then you pick this 10, 10 plus 9, you have 19. And then 19 plus 1, you have 20. So that is the cumulative frequency we can get from the frequency we have here to give us another information. Then we go ahead and finish the last two. The last two, CRF, cumulative relative frequency. I give you the formula as C.R.F is equal to the...
Yes, sir, please, sir. Can you go back to the cumulative frequency?
Yes, so the cumulative frequencies, those of you who have forgotten how it is done, I'm saying that, sorry, let me go back to the screen. I'm saying that those of you who have forgotten how to do it, I'm saying that for the cumulative frequency, you pick the frequency here, the first row, and then you repeat it. So you pick the 2 and you repeat it. Cumulative means that keep adding up. Keep adding up. So when you pick this 2, there is no number above it to add to the 2. So you write it. You repeat the same thing as 2. But when you come to the second line, which is 3, you can't just write 3 because there is 2 above 3. So you just add this 3 to this 2, and then that will give you this 5 you are seeing here. That is the second line. The third line, when you jump to this 5 also has 2 other numbers on top of it, 3 and 2. So you have to add all of them. So it becomes 5 plus 3 plus 2. That will give you 10. And that's the 10 we wrote here on the third line. And then you jump to the fourth line. The fourth line, 9. The numbers above 9 are 5, 3, 2. So you add them to the 9. So you have 9 plus 5, 14. 14 plus 3, 17. 17 plus 2, 19. And that was the 19 we wrote here. Then finally, you come to the last line. The last line, you have 1. And the numbers on top are 9, 5, 3, 2. So you add them to the 1. So you have 1 plus 9, 10, 10 plus 5, 15, 15 plus 3, 18, 18 plus 2, 20. And that is the 20 you are seeing here. Are you okay with it now?
Yes, sir.
Yes, sir. Yes, sir.
Very good. Yes, Ramatu, Serafina, I've seen your hand up. What
Yes.
did it say?
For the cumulative frequency, I also saw that you added the what's the name? The 2 plus 3 to get the 5. Can you also do it like that?
Yes, so that's what I said. That if you like, just repeat, go down, any add it to the current number and record. That is what I just did.
Okay. Thank you.
Okay. Right. So let's move on to the CRF, cumulative relative frequency. I said this is the row cumulative frequency divided by the total frequency. The row cumulative frequency divided by total frequency. So these are the row cumulative frequency 2, 5, 10, 19, 20. So you are going to help me again with your calculators. We are now going to divide these numbers by the total frequency. So we start with the first one. 2 divided by 20. I'm sure you get 0.10 for the first one. Then the second one, 5 divided by 20. You have 0.25. Very, very good. Then the third one, 10 divided by 20. You have 0.50. Then 19 divided by 20. What are you having?
0.95.
0.95. Then last one, 20 divided by 20, you get 1.00. Very good. So let's finish up with the last column and then begin writing our information down. The last column, CPF. CPF is CRF multiplied by 100%. CRF multiplied by 100%. So these same values you are seeing here, we are just going to multiply them by 100 and then we record. 0.10 multiplied by 100%, you have 10%. 0.25 multiplied by 100%, you have 25%.
Sir, please, how did you convert it to the percent? You know, I think it should be 0.10. No? How did you convert it to percentage? You know?
Okay, so I'm saying this is the calculation we are doing. The first one, 0.10 times 100%. So this percent, just put this percent here like this. And then multiply 0.10 on times 100 on your calculator. What are you getting? 0.10 multiplied by 100.
10.
Very, very good.
Sir.
That was why we had the 10%.
Okay, thank you, sir.
Right. So you do the same to the rest. 0.50 times 100%, you have 50%. 0.95 times 100%, you have 95%. And then the last one, 1.00 times 100%, you have 100%. And this completes our table. And then we are now going to look at the most important aspect of what we have done, because we were given a raw data about the choices of 20 guests, and they just gave their choices and they went. But you as a manager, you should be able to do analysis about the choices that people have made to check whether they are okay with your accommodation, there is an improvement to do, or the information you are going to get is going to tell you that you are on course. There is no problem. Continue. And that is what I said last week, that our main fix is because of the roadmap I gave you, that we shall always be given business data. So the question we are treating is a business data. Why? Because they are raw. They are just raw. We can't make plenty meaning out of the data. So what do? We need to process it to become business information. And so the table you have seen there is a business information table. The table we have done where we started from the classes, the tally, the frequency, the relative frequency, the percent frequency, the cumulative frequency, the cumulative relative frequency, and then the last one, the cumulative percent frequency. That table is representing our business information now. So the next thing we do is we are going to the business information table to now see how we can make quality business decision out of the table, because now we have left the data stage. We have left the business data stage. We are now at business information. Let's see how we can make use of the information we have. So I'm going to guide you to write a couple of information from the table. As your understanding increases, I'm sure you can also write your own information from what you are seeing in the table. Now, this is the first information I want to write for you. Information number 1. So we write that guests that chose above average, guests that chose the above average rating of the accommodation were 9. Guests that chose above average rating of accommodation were 9. And they formed so this is why I chose the 9. This is why I chose the 9. They were 9. And they formed, then I jumped to PF, and they formed 45%. They formed 45% of the total guests of 20. So that's the first information. We are targeting the highest. Guests that chose above average rating of accommodation were 9, and they formed 45% of the total guests. And it's all in our table. This is the 9 I picked. This is the 45% I have picked. I'm not done with the information. I'm just showing you how to interpret the information or the numbers you are seeing here. Information number 2 that we can write from this. In fact, we can write as many as 20 different information on this. But because of time, I'll just do a few, and then that will serve as a guide for you to be writing the other information. So information number 2, we are still on this one because that's where our interest is, the same place. Information number 2, we can say that all those who did not choose, all those who did not choose the excellent option, all those who did not choose the excellent option were about
Hello, sir.
Let me finish.
Hello, sir.
Let me finish.
Okay.
Let me finish. All
Okay.
those who did not choose the excellent option were about 95% of the total. Look at another information I'm extracting, and I'm going to show you where you can see it in the table. All those who did not choose the excellent option were about 95% of the total. How did I get this? When I come to the table, all those who did not choose the excellent option means poor, below average, average, above average. That's 4. 1, 2, 3, 4. They did not choose excellent. How did I get the 95? I went straight to the CRF. Look at the CRF. Cumulative means you are adding up. Look at the CRF. The CRF, if you get here, above average, from poor to above average, we had 0.95. 0.95, when you look at the CPF, it is 95%. So it means that 95% of the people didn't choose excellent. It means it's only 5% of the people who chose excellent. That is another information that you can write from here, and I have picked. Now, finally, I'll let you ask your questions. The final information I want to write, because me as a businessman, I want to put all the information together to know whether what the people are telling me, my facility is okay or it is not okay. So this is what the third information I want to write for you before you ask your questions. I will allow you to ask your questions. But let me write the final information for you. Now, the final information I want to write is that number 3. Now, excellent means they are okay with the facility. Above average also means they are okay with the facility. Average also means they are okay with the facility. But below average means they are not okay with the facility. Poor also means they are not okay with the facility. So we can say that if you look at the percentage, look at it, 10% for poor, 15% for below average. So you can say that 25% of the guests were not okay with the accommodation. But, because we want to capture all, but 75% were okay. Where did we get the 75%? We added the percentages of average, above average, and excellent, like I was arranging here for you. So 25% of the guests were not okay with accommodation, but 75% were okay. So me, if I'm a manager, and then I see this information that 25% were okay, it means thumbs up. It means I've done well. It means I'll say majority of them are okay with the accommodation. It's just a few minority who say they are not okay. And in business, when 75% of your clients or clientele base are still doing business with you, and 25% decide not to do business with you, I don't think you can stay out of business. It means that you can improve. The 75% is an encouragement that there are little things you fix, which the 25% people were not happy with. So like I said, just this information table, we can write so many reasons from it and get information. Then based on the information, we can now take a decision. I've just written 3 out of the so many we write. But look at it. When we started, this is what we had. How did we know there's some 25% who are okay, who are not okay, and 75% who are not okay? We didn't know this because the data was raw. This is a raw data. So what we have done is we have processed this data using what we have learned today. The frequency distribution analysis is helping us to get information from this raw data you are seeing here. And so at this point, I will open the floor for your questions. I just needed to show you how the information table is arranged and the meaning we can make out of the table. And I'm sure you can also be writing, picking your information one after the other from it. So, Jonathan, please go ahead and ask your question. Okay, I think, Jonathan, we can't hear from you. Any other question? Yes, go ahead.
Good afternoon, sir.
Good afternoon.
Please, the first question is that, you see, with the point 2 that you said, all those who did not choose the excellence options were about 95% of the total.
Yes.
And then we tracked it to the cumulative percentage frequency.
Yes.
Right, that is at 95%, which means that the 5% of the excellence, it's only 5% who chose the excellence. So exactly. I'm saying that, let's say, if you want to also choose those who actually selected only, those who did not also choose, let's say, below average, are you going to select, let's say, 25% for that?
Very good. So the same way, those who did not choose below average, all you do is that below average was 25%. So you just subtract this one from 100%. When you subtract this one from 100%, that will give you 75%. So it means that 75% did not choose below average. Are you getting me? Your network is not helping you. But if I
okay, yes, sir. I got it.
I do you understand the question?
Yes, sir. I mismatched the 95.
Okay.
Yes, sir. Yes, sir.
All right.
I thought that 95 was right before the excellence. Yeah. Thank you, sir.
No. It's coming from the top. The excellent here. You see, when you keep adding from the top, then you come and get 100. So from the top, 1, 2, 3, 4 are forming the 95. So it means that when you take it from 100, this will form only 5% when it's standing alone. If you are picking the first two is forming 25%. The first one is forming 10%. The first two is forming 25. The first three is forming 50. The first four is forming 95. That is the order.
Yes, sir.
Right. Any other question? Okay, so like I said.
Yes, sir.
Yes, go ahead.
So in this case, all those things you wrote were not given in the question.
Yes, they were not given in the question, but the question I can ask you on this one, which I didn't write here, is that I will tell you that a question. So from the above, from the above data, extract from the above data, extract about 10 different informations. 10 different information for decision making. For decision making. And I can ask you this in exam. I just want to see how you think as a business person after analyzing data. So that's the question I'll ask, that from the above data, extract.
Okay, sir.
Yes, extract means look out. I want information that this data is raw, is too raw for me. I know there is information inside, but I can't see it. So use a process to get me information, or I can even specify that use the frequency distribution analysis to extract 10 different information which can be used for decision making. And so like my third information I gave you, which I like so much, look at information number 3. I'm saying 25% of the guests were not okay with accommodation, but 75% were okay. This is what every manager wants to hear. That what are the people saying? You can't go when the manager asks you, what are the people saying? You can't just go and say that the people are saying that the accommodation is below average, above average, average, excellent, poor, above average, below average. It doesn't make sense. When you start speaking like that, you are speaking data. You are not speaking information. Because data is raw. This is raw. Your manager cannot process this in his mind. But when you are able to use the frequency analysis to do what we have done, and then you show him this picture, this information table, which we call empirical. This is empirical evidence. It's not something you wrote from your mind. You took it from the data. So this is empirical evidence from the data. Okay. And the evidence from the data is saying that 25% of the guests were not okay with the accommodation. Why? Because they chose poor. They said the accommodation is poor and the accommodation is below average. When somebody speaks this language to you in your business, you will not be happy that your product is poor, your product is below average, or your services are poor, your services are below average. Nobody wants to hear this. But when you hear people say, okay, your services are average, it means there is more room for improvement. That's what the person is telling you. That when your services is average, it doesn't mean it is bad, but it means that there is more room for improvement. When another person says your services are above average, I'm sure you'll be excited here. When somebody tells you your services are above average, okay, it means that still there is more room for improvement. Then when they finally say this is an excellent service, this is a top-notch service, I'm sure you'll be much, much, much excited, because in that case, you don't need any improvement. They have scored you excellent. So when you tell your manager that the 20 people who came to sleep over last night, about 75% of them are saying our accommodation is okay, I'm sure you'll be excited, meaning that only 25% said it wasn't okay. Assuming it was the reverse, assuming 25% rather said it was okay, and then 75% said it is not okay, I don't think your manager will sleep. It means that something will have to be done. So this way of analyzing data brings out a certain picture whereby even though the data we had didn't come with numbers, these data were words, but we've been able to use numbers to get percentages out of that, which are speaking some good business language to us. That how did you use all these words and then you converted them into a nice table like this, where you are having numbers that are speaking for the activities that are going on here. And that's the first example I wanted us to do today. We have qualitative data and we have quantitative data. This is a qualitative we have processed. Let's go and look for a quantitative data and go through the same process to see
hello,
them.
Sir.
Yes. Yes.
This is Harrison. Good afternoon, sir.
Yes, good afternoon.
Yes, sir. So my questions are two. Let me take the first one from this. The business information that we have derived, the possible business information we have derived. After getting them from the business data, you need to take business decisions. So from this business information that we have derived, specifically the three informations, what are the possible business decisions that the said manager will take?
Yes, good. Second question.
And then the second one, from the frequency distribution analysis, that is the table, we realize that from the frequency column, all the other columns, there is a formula for them, except the cumulative frequency. And the question is there an established formula for calculating the cumulative frequency, or you just have to do it by yourself like we did?
Okay, good. So the established formula, yes, I get you. Now. Let me answer the second one first. The established formula for the cumulative frequency you are seeing here is this. New frequency is equal to old frequency plus current frequency. So I repeat, new frequency is equal to old frequency plus current frequency. So let me demonstrate. Now, this is the new frequency. This is my first new frequency, 5. How did I get this 5? I'm using my formula. I use the old frequency, which is 2. And then I added it to the current frequency, which is 3. Because I want to come to this line. Line number 2, there's already a frequency. So line number 2, this is the current frequency 3. But before line number 2, there was line number 1. So line number 1 is the old frequency. So you add the old frequency to the current frequency to get the new frequency. So old frequency 2 plus current frequency 3 will give me new frequency 5. The moment I get here and I want to move to this line, the process starts again. 5 now become 5, which is new frequency, will now become old frequency 5 plus current frequency 5. That will give me a new frequency of the 10 you are seeing here. Then when I want to come to this line, to the 10, which is the new frequency, will change to old frequency. So you have old frequency 10 plus current frequency 9. That will give me the new frequency 19. So 19 becomes my new frequency again. And then when I want to move to the last one, 20, the 19, which was new here, now has now become old. So old frequency 19 plus current frequency 1 will give me the 20 you are seeing here. So if you want an established formula, that is how you can use to get the cumulative frequencies. Then back to your most important question and good question, that after you write all these informations, what decisions are you going to make? And those are the things we write as recommendations. What recommendations are you going to make to improve the hostel facility? Let's take them one after the other. Let me start from the back. 3, 25% of the guests were not okay with the accommodation, but 75% were okay with the accommodation. So we need to know from here, we need to know why this 25% were not okay. We need to know. Probably when we are filling forms, you see that sometimes you give some option, any other comment. Any other comment. Okay. So when you look at the any other comment formula, form, maybe the person has written that your bed was bad, I couldn't sleep. Your bed was bad, I couldn't sleep. Or the lightning system is bad. Or the water system is bad. So then if the person was in maybe room number 20, quickly you go and verify whether that room number 20, indeed the bed is bad, the water is not working well, the lightning is bad. Then quickly you fix it. The person has given you a good information that I don't like this place because of this. So you quickly go and fix them. As for the people who said, okay, there's no need going to their room. But those who said not okay, the recommendation and the decision is that go there, check their comments and find out whether what they were saying is true or they were just writing anything for you because they just want to feel something and go. And that is the decision you can take there. Then information number 2, all those who did not choose the excellent option were 95% of the total. So what decision do you take here? This is a very big percentage, very big, that only 5% said your accommodation is excellent. It means that you haven't gotten there. If 5%, only 5% are saying it is not, then you ask yourself, why did the 95% people didn't choose? Why didn't they choose excellent? I'm sure when you also look at their comments, they will be pointing some things you can fix. Maybe some will say your windows are not properly done. Some may also say there was leakage in their room. Some may also say the cleaners didn't clean their room very well. And I'm sure you get information from their forms, this 95%, and then use it to improve the system. Then the first information, those who chose above average, they were the highest, 9 out of 20. And they were forming 45% of the guests who slept there. 45% in approximation will say it is closer to half. It is closer to 50%. If we apply one significant figure to 45, we'll get 50%. So in other words, 50% are telling you that the accommodation is above average. This is a good starting point for you. It doesn't mean you should rest. It means that you have a starting point now, that 50% of your guests are saying your accommodation is above average. Then the question is, those who did not say it is above average, you will still go back to this 25% and go and check the problems they pointed out, and then you fix. So you see that most of the information are intersecting. They are moving into one another. And that is how you can have your business decisions from the information we have written. And that is the objective, actually, of this course. Get your business data, get business information out of it, and then go ahead and extract your business decision. All right. So quickly, let's look at a quantitative data, and we then go through the same process. So this is a quantitative data. This is about an auto shop. It says that the manager of an auto repair shop would like to get a better picture of the distribution of costs for some common car spare parts he is selling or has sold. Now, the manager has taken a sample of 50 customer invoices just to check the cost of the spare parts written on the invoices, where all the money has been rounded to Ghana cedis. In other words, the first invoice, the total amount on the invoice was 91 cedis. The second invoice was 71. The third invoice was 104. The fourth invoice was 85. The fifth invoice was 62. So these are for 50 invoices that he has generated from the sale of spare parts. So he wants to get a better picture of the money that are on the invoices. Then he can know whether some other thing must be improved. And so he's trying to put this data into information, and then with the information, whatever recommendation from the information will help him to take a decision. So I'm saying process this table for the above data, just like we did for the previous one. And this type of data is called a quantitative data because it's coming with numbers, unlike the first one we did. This is a quantitative data. Okay. So because we have 25 minutes and you know the processes we go through, I'm going to shorten things for us to be able to meet our closing time. So in the same way, we are going to do a table like we did. I've done some here. Let's continue. So this is our classes. This is our classes, the cost. All spare parts costs that are between 50 to 59. We'll go and tally and get the frequency. All spare parts between 70 to 79. So we are going to arrange it like this, like we did the first one, and then we can come and write some information about it. So I will start here and then continue. So from this side, this is the way we should have started. We have our first column here, the classes. So I'll collapse one for you to see. We have the classes here like this, which I have here. So I will just use the one here and then extend it so we don't waste a lot of time. Now you know how to do these calculations. So I'm going to import the 8 columns we did. And then we do the analysis. Okay, so let me complete it here. And then I'll collapse the middle one. And we continue. So for the classes, if you look at the spare parts cost from the question, you first of all target the least number. The least number is 52. And then the highest number is 105. So how do you form your classes? 52 means that we should start in the 50s.
Yeah,
So
109, sir.
the highest 109.
109, thank you. 109, thank you. So it means that you start, once you are in your 50s, you start in your 50s, 50 to 59, and then you continue 60 to 69, 70 to 79, with the idea that you move until you get to the highest 109 and then you stop. So that is how it was done here: 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99, 100 to 109. So if you do your tally like we did in our first table, the tallies will come right here before the frequency. So that's what I want to do in this that we are doing at this side. So we have 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99, and then 100 to 109. So let me collapse this one. I don't need this one any longer. Okay, good. Then we have our tally. Then we have our frequency. Then I have the relative frequency, percent frequency. Then from there, we have our cumulative frequency. Then we have our cumulative relative frequency. And then we end up with cumulative percent frequency. So because I've done this one already, let me quickly write the frequencies for you. I know you can do the frequencies by now. The frequencies for these ones are, as you see over there, the first one, 50 to 59. If you tally the numbers, you have 2. The second one, you have 13. The third one, you have 16. The fourth one, you have 7. The fifth one, you have 7. And the last one, you have 5. When you add everything up, you get 50. So I'm just going to repeat them there. So the frequency, the first one is 2. The second one is 13. The third one is 16. The fourth one is 7. The fifth one is 7. And then the last one is 5. Then the total you will have 50. So the tally, the first one was 2. Second one, 13 means 1, 2, 3, 4, 5. Another 1, 2, 3, 4, 5. And then 1, 2, 3, 4 mean the 13. Then the 16, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then you have 1 hanging in there. 1, 2, 3, 4, 5. 1, 2. For the first 7, 1, 2, 3, 4, 5. 1, 2 for the next 7. Then the last one, 1, 2, 3, 4, 5. So these calculations, we have done it today. We said these calculations, all you do is that the relative frequency is the raw frequency divided by the total frequency. So that is it. The first one, 2 divided by 50 on your calculator, you have 0.04. 13 divided by 50 on your calculator, you have 0.26. 16 divided by 50 on your calculator, you have 0.32. You can be checking. 7 divided by 50 On your calculator, you have 0.14. 7 divided by 50, you have the same thing. 5 divided by 50, you have 0.10. And like I said in the first example, when you add all the relative frequency, your total should be 1.00. That is what can guarantee you that what you have done is correct. Then you change the relative frequencies to percent frequency like we did. So you multiply this one by 100%, you have 4%. Multiply this one by 100%, you have 26%. Multiply this one by 100, you have 32%. You multiply 0.14 by 100, you have 14%, 14%, 10%. When you add all the percentages, you must get 100% to validate what you have done. So that is the percent frequency. And like Harrison was asking me about the cumulative frequency, we repeat the first one too. So old plus new, current, old plus current, 2 plus 13, you have 15. 15 plus 16, you have 31. 31 plus 7, you have 38. 38 plus 7, you have 45. 45 plus 5, you have 50. So the cumulative frequency is done. We are left with the last two columns where we need to use our calculator one more time. We are doing the first one. We do 2 divided by 50 as our first one, and you have 0.04. The next one is 15 divided by 50, and you
0.3.
0.30. Very good. I just want us to always keep it to 2 decimal places. Then 31 divided by 50.
0.62.
Very good, 0.62. Then the next one is 38 divided by 50.
0.76.
Good. Then 45 divided by 50.
0.90.
0.90. Very good. 50 divided by 51.00. Very good. Then finally, we convert this one to CPF by multiplying this by 100. So you have 4% here. You have 30% here. You have 62% here. You have 76% here. You have 90% here. And then you have 100% here. So it has become like the first table we had. And there are several information. So look at some information I picked. I just picked about 4 information here for you. And there are several you can pick. If I say 10, look for your information and write. Now, this is the first information I wrote here. I said only 4%, only 4% of the spare parts costs are in the range of $50 to $59. Where did I get this 4%? I just look at the first line. Look at the first line. All spare parts costing $50 to $59. I realized that this 4% is showing me the percentage of invoices that are having spare parts costs between 50 to 59. So this is one information you can write because we can see it in the table. And then like Harrison asked me, what decision are we going to take with this? Which I feel he has asked an excellent question. What decision are we going to take with this? Now, this is what he's telling us, that all spare parts cost between 50 to 59, we only have 4% of the invoices showing that. So it means that all prices that are more than $59, all prices that are more than $59 are constituting 96% of the invoices, which is good for the business. It means that the lowest amount you have sold or the spare parts that do not cost is just forming 4% of the invoices the manager is having. But the rest of the 96%, which is more than $59, it means that more money will rather come from it than this one. After all, any amount that is more than $59, you'll be happy with that. Example, if I have invoices which are 10%, and the 10% is coming from amounts that is between $100 to $109, I should be happy, because $100 to $109, I have 10% of the invoices having that. But when I come to the lowest, 50 to 59, it is only 4% of the invoices that I'm having as money coming from $50 to $59. So that then the decision to take is that I will not focus on spare parts that are bringing small money. If at the end of the day, it's only 4% of the invoices that are going to show such money, I'd rather focus on the ones that are higher than this. Then the second information I picked out, I said 30% of the spare parts cost, 30% of the spare parts costs are under $70, which is also not good for me. 30% of the spare parts costs are under $70. And where did I pick the 30%? If I add this 4 to 26, I'll get 30. And this 30 is covering all spare parts costs between $50 to $69. This first two. So if I say 30% of the spare part costs are under $70, it means that they are not up to 70. And the table is showing it here, that indeed the spare parts costs that we have on the invoices that are under $70, they are 30%. That is another information. The fourth information is 10% of the spare parts cost are $100 or more. And that was where I jumped to. 10% of the spare parts cost are $100 or more. Indeed, when you look at the last line, the cost here is 100 to 109. And how many invoices gave that? 5 different invoices gave spare parts cost, which were more than $100. In terms of percentage, it means 10% of the invoices were giving spare parts costs, which are $100. Now look at how the question started. The question started this way, that the manager wants to have a bigger picture. He wants to have a better picture about the sales he has made. The 50 invoices are coming with different amounts. He wants to know whether at the end of the day, good sales have been made. That is a better picture. So from the table I'm seeing, let's see the better picture he will see. Out of the 50 invoices, All invoices that had more than $100, they were 5 out of the 50. All invoices that had between $90 to $99 were also 7. All invoices that had $80 to $89 were also 7. And then finally, all invoices that had 70 to 79 also were 16. Now let's look at the bigger picture. So it means if we add the 16 to the 7 plus 7, 14 to the 5, we are going to have 35. So the better picture is having now is that 35 out of 50. 35 out of 50 invoices had spare parts amounts that were more than $70. And I feel this was a good day for him because anything below $70, according to their operation, is not too good. So if 35 out of the 50 invoices or sales you've done a day is more than $70, then the better picture is that the business went well. The business went well on that day. If I'm to bring this into our local currency, assuming we are using the rate of 12 cedis per dollar, all the manager is trying to check is that 12 cedis times $50, that is 600 cedis. So what we are saying here is that the invoices the manager is having, all the invoices that have an invoice amount that are more than 600 cedis is 35 out of 50. That is the meaning of under $70. All the amount that are more than that. And when we check the invoices, we are seeing that the $70 starts from here and then it ends somewhere here. Whilst the $50 and the $60 are in this range, that is forming the 30%. So 30% of spare parts under $70, meaning that 70% of the invoice amount are more than $70. And that is the information we can have for splitting this into two. That if the minimum you are supposed to get, on each of the invoices should be $70 for good operations, that your target is that if you have 50 invoices and all of them are showing $70, when you multiply $70 by the 50 invoices, it means the minimum amount of money you should have for that day should be $3,500. And anybody who sells spare parts getting $3,500 a day, you can say this is a good business. But unfortunately, the 50 invoices the manager has, some of them are less than $70. So he wanted to have a better picture about it. And the picture is that 15 of the invoices are less than $70. But 35 of the invoices are more than $70. This can be our conclusion, that 35 of the invoices are more than $70. And then 15 of the invoices are less than $70. When you compare the two, this will give us better money as compared to this one. If it were to be the opposite, then it means that business didn't go well. So several information that can be picked from the table, and then a decision will be taken. So back to Harrison's question, what decision do we take from this information? The decision we take from this information is that the 15 invoices that were showing less than $70, we need to find the items that were bought. And then if we shouldn't invest too much into it, let's not invest too much into it, because if you go invest too much into it, it will lock your money up in stock. It will lock your money up in stock, like we say in business. Your money will be locked up in stock, so you don't invest too much into it. Any question? Our time is up. So,
hello, sir.
All right, sir.
Yes, I believe with these two examples, any question I bring concerning quantitative data or qualitative data, use your own understanding to write the information. Once you get the table, just use your own understanding, your own English to be writing anything you are seeing. You just have to explain to me that, okay, from here, this is the meaning, that's the meaning, this is the business decision. And then I can see your creative mind at play. So it is a free place that you can express yourself about how you are seeing the analysis of the data, as well as the corresponding business decision that must be taken. On that note, we want to end the class for today.
Hello, sir.
Yes.
Hello, sir.
Yes.
Yeah, I wanted to ask the class intervals for the quantitative.
Okay.
Are you supposed to, like, is it going to be given to you, or you have to now devise it your own way?
Yes. So you have to devise it your own way, but for the purposes of all students being on the same page during exams, I will have to give it to you. So I'll state the range. Yes. In the
Thank you,
exams,
sir. That's my question.
yes,
All
I'll
right,
show
sir.
you.
My question.
Sir,
Okay.
during the exams, should we show the calculation, or we just move from the raw data to information, then we use it to solve the decision?
No, you show everything. I normally mark rough work too. So show everything. When you do any rough work, don't cancel
Okay,
it.
sir. Yes,
Yes,
sir.
I mark rough. I award marks for rough work. So you can show the rough work, you can show the table. I'm okay with it.
All right, sir.
Okay.
Yes, sir. So from the data, from the
Yes.
quantitative data, the table,
Yes.
we see that the frequency or the tally
Yes.
is always equal to the sample size, which is in this case the 50
You are
invoices.
right. Yes, you are right.
Now, the relative frequency, we're also told, or we learn that it is always should be equal to 1.
Yes.
The relative frequency.
Yes,
Now,
you are right.
is there an explanation why the RF is always 1?
Yes, there is. And then
Yes,
there's also an explanation why the percentage frequency is always 100. Okay, so it is always 1 because the highest decimal you can get, no, let me put it this way. Let me put it in terms of proportion. The highest proportion you can get is 1.00. That's the highest proportion. This is what I mean by highest proportion. Anytime you have, I'm trying to go back to the data. Just give me a moment. Let me correct something here and then. Our time is up, but let me explain your question and then we can close. It's okay there. Okay, I'm still having issue. So what I'm saying is that anything you have, it is called whole. WHOLE. My pencil is worrying me. Moment. Okay, good. This is where I want to come to. System is slow. I want to be writing something. I'm looking for a page. Okay, so I think it's good to go now. Now, this is what I'm saying. Anytime you have something like an orange, in proportion, we call it whole. The moment you strike it, we say that you have stricken it into parts. So let me give you an example. The normal orange we take, when you divide it into 4, there are 4 areas. 1, 2, 3, 4. So when you take 1, we say you have taken 1 out of 4. When you take 2, we say you've taken 2 out of 4. When you take 3, we say you have taken 3 out of 4. And then when you take 4, we say you have taken 4 out of 4. Very good.
Which is 1.
Very good, which is 1. So the idea is that if this side is, like we say in Ghana, 1/4, this is also 1/4. Anytime you pull 1, it's 1 out of 4. So this is also 1 out of 4. This is also 1 out of 4. When we want to get this orange back, and we, like we've done here, you've taken the first one, 1 out of 4, second one, 1 out of 4, third one, 1 out of 4, last one, 1 out of 4. Now we want to put all of them together. They were parts. We want to put them together to get a whole again. What do? We take the first 1 out of 4, we add it to the second 1 out of 4, we take the third 1 out of 4, and then we add the last 1 out of 4. When you find LCM for this, you have 4, you have 1 plus 1 plus 1 plus 1, and then you have 4 out of 4, which brings you back to the whole 1. So the relative frequencies you are seeing here, if you look at the formula we were using, we said relative frequency is equal to the row frequency divided by, very good, total frequency. That's the 1 out of 4 thing I want to explain to you now. Okay. So the 1 out of 4, the 1, 1, 1, 1 you are seeing on the top there are the row frequencies. And then the 4, 4, 4, 4, 4, 4 you are seeing down here is the total frequency. So we had this one because we did some calculation with the frequencies we had. And these were the frequencies we had. So it means that first one we had 2 out of 50 plus, then the next one 13 out of 50 plus the next one 16 out of 50 plus the next one 7 out of 50 plus the next one again 7 out of 50 plus the last one 5 out of 50. Now check. when you add the top, 2 plus 13, 15. 15 plus 16, 31. 31 plus 7, 38. 38 plus 7, 45. 45 plus 5, 50. So you come back to 50 out of 50, which will bring you to very good. So that is the reason why always the relative frequency will bring you back to 1. If you don't get 1, it means you have made an error in the process you undertook here. And I'm sure that should be the last question because your time is up. On that note, we will end the class here and then continue next week, God willing. I wish you a good week. The meeting is officially ended.